So this question is about the statistical decision tree. In other words, which statistical analysis will you use under each different problem here? So what you have to do is identify the variables. Once you know the variables and what type they are, whether they're categorical, ordinal, or continuous, then you should know the test. So the first one is people with blue eyes tend to drive blue cars. So eye color is a categorical variable, right? You got brown, you got blue, you got green, right? That's the first categorical IV. And car color is also a categorical variable, right? So you got blue cars, white cars, black cars. So you're comparing two categorical variables. There's only one test that does that, and that is the, hold on, that is the chi-squared test. It's not on there, hold on. That is the chi-squared test of independence. Boom. Second one, if there's a significant difference. So difference right there should tell you that it's either a t-test or an ANOVA. And the DV is annual salaries, which is a continuous variable. And you got police officers, firefighters, officers. So you got three groups. So three groups, that's your categorical variable. And annual salaries is your continuous DV. That has to be a one-way between group ANOVA. Boom. Next one. If there is a significant difference, again, difference means t-test or ANOVA in marriage satisfaction scores between husbands and wives. So husbands and wives, that's a variable with two levels, right? Husband or wife. So you could just say, married with, and it's got two levels. So that's going to be a t-test. Independent t-test. Where are you? You are independent t-test. Independent t-test. There it is. Down at the bottom. Again, you can't see it, so it's at the bottom here. It's an independent t-test. And next one. If stress levels, that's a continuous variable, decreased after a session of yoga. So there's a pre and a post. Pre and a post that should automatically tell you, pre and a post, you're going to do a paired t-test. Right? There's only one group. That makes it a paired t-test. Next question. If the amount of money spent on marketing, that's a continuous variable, and the number of commercials played on YouTube would predict sales. So you got two predictor variables. How much money is spent on marketing and how many commercials are played on YouTube. Those are both continuous variables trying to predict sales. The word predict tells you right off the bat it's a regression. And if it's got more than one IV, it becomes a multiple regression. So that's your answer for that one. Next one, if the temperature of the day, that's a continuous variable, is related to the total number of ice cream sales. So related doesn't say predict, it just says related. That means it's a correlation, right? Because you got temperature, which is a continuous variable, and ice cream sales, which again is another continuous variable. So only the correlation looks at two continuous variables. Next question. If job satisfaction increased over a 5-week period where all employees attended a weekly meeting with a consultant and their job satisfaction scores were measured every week. So only one group, but 5 repeated measures. That is a repeated measures ANOVA or a within group ANOVA. So I'm going to say that one. Next question. If there was a significant difference, again, difference means t-test or ANOVA, between the school's average GPA and the GPA of the football team. That's probably a one sample t-test. Where's that one sample t-test? One-way t-test. Because the football team is part of the school as a whole. So the football team would be the sample, and the whole school would be considered the population. So that's probably a one-way t-test. And last but not least is how many males and females there are in a company. That's not really a test, right? They're not measuring anything. Just how many males there are and how many females there are in a company, that is not a test. So is that one of my options? Right? This is not a statistical scenario. And that's it. I hope that helps. MGZ out.